All right, so like I said, today we're going to talk about the building blocks of geometry, and the reason that they're called the building blocks of geometry is because they are the most fundamental, basic geometric objects that are out there. There are 3 of them. Anybody have any ideas what one of them might be? Yes, Jed. A square. Square's pretty complicated though. Square's got some angles, it's got some sides. Okay, even simpler, way down. Most that everything else is. Okay, good. One of them is a line. Okay, so that's the level that we're talking about. So you're way too advanced for us. So even smaller than a line is a line segment, which we'll get to in just a second. But even smaller than a line segment is a point. Good, a dot or a point. And then what happens if we, okay, so we'll talk about the third one in a second. Let's start with a point, because that's the most basic thing. And when you were brainstorming, you talked about a point as having location, right? Okay, so a point is basically a location in space. All right? How big is a point? Is a point this big? Nope. Bigger or smaller?
Smaller.
Is a point this big? Smaller? How big is it? It actually has no size. It is kind of a trick question. Okay? Because if you think about it, if you think about the idea of a point defining a location, if a point had any size, then that would mean that you could move around a little bit on that point, right? But as soon as you move, then you're in a different location, right? So then you're at a different point. So the weird thing about points is that it holds a location, but it doesn't have any size. So that's kind of a crazy thing to think about, but that's what we're going to ask you to believe and accept. All right? So now that we kind of know what a point is, how could you take the idea of a point and extend it to think about the idea of a line? Okay? So that
Stretch it out.
okay, so if you take the point and you stretch it out, or how about if instead of stretching it out, you like, yeah, I was going to say line a bunch of them up, but we can't, that'd be cheating. But do you guys understand Reed's idea? If you take a point and you kind of stretch it out or extend it, okay, then you would get a line. How far does a line go? Right, forever in both directions. And so, how many points are in a line? Infinite number of points, right? Because a point has no size. So if you're going to line a bunch of them up, then you're going to need an infinite number of points. So a line we're going to think of as being an infinite number of points. And we're going to use this idea of Reed where you're kind of stretching it out. So infinite number of points stretched forever in both directions, something like that. We talked about lines when we were brainstorming on Friday. Okay, so you're starting with a point that has no size at all, and then you're putting an infinite number of things together that have no size, and magically you have something that has size. So again, you pretty much have to understand that I'm lying to you right from the beginning, because A, how can something have no size, and then B, how can you put a bunch of things that have no size together and magically get something out of it? But you're stuck with me, so you're going to just have to deal with the liar. How many dimensions is a point? I'll give you a hint, it has no size. So it's no dimensions, so this is 0 dimensions. How many dimensions does a line have? one. A line is one-dimensional because you can just go one direction on it, and we're not counting backwards and forwards as two different directions. So you can sort of think about it as you can go sideways. Okay, so you can only go one direction on a line, so that means it is one-dimensional. How about if you take this and make it two-dimensional, what do you get? But an angle is kind of made up. Yeah, I see what you're going with there. Kind of. So again, Reed took this one point and stretched it out and made a line. Okay? What if you have a line and it's already stretched out this way? What's another direction that you could stretch it out then? Up, is that where you're going up in the, yeah, okay, so what if I took this, think about this line, if I take that and stretch it out this way, then what do I get? Yeah, then you get a plane, okay, good. So that's what I'm trying to kind of get you to get there. So plane, how does it look? Okay, so it has length and width, so it's got two dimensions. But, strangely enough, since it's made up of lines, and lines are made up of points, and points have no size, it's got length and width, but no thickness. And that is, because it has length and width again, it is two-dimensional. And so that's the world that we live in, right? So that's mostly what we're going to talk about is what's happening in planes, and technically this class would be called planar geometry, because we're really only dealing with flat surfaces, things that happen on planes. Because funny things happen when we get onto curved surfaces, and we'll talk about that later, but not today. Okay? How are we doing so far? Great. Okay. These three things also have another fancy name together. They're called undefined terms. Because when you start talking about things that have no size, you start talking about things that have no thickness, then really they're kind of just things that we understand what they are, but as soon as you try to nail them down and use really specific language to define them, then weird things happen. So we just call them undefined terms that everybody just understands what they are, and then we're going to go from there. Okay? So the book has some representations of these things in the real world and also in class. They show this poppy seeds on the side of a bagel could be representations of points. In this class, we'll make a big old dot like that, and we usually use capital letters for the points. So we call that P, just for funnies, right? Lines, since we talked about they extend forever in both directions, have arrows on either end, all right? And they can be named in a couple of different ways. I could make a little cursive letter like that. That's a cursive L, and so that tells me that that's line L. Or if I wanted to, I could put a couple of points, label a couple of points on there. What would you like to call those points? C. So I'm going to call one of them C. And I'm going to call the other one A. Okay. And so since points A and C are on that line, I could also call that line AC. A little double arrow on the top there. Okay. And then the planes are really, really wacky, and luckily we don't have to draw these very often, but I think I can cheat out a parallelogram here somewhere. The planes, they draw by making parallelograms, and it's supposed to give you the idea of, like, it's not flat on the board, it's sort of coming out at you a little bit. Do you see that at all? Sort of? Okay. We don't draw very many planes because usually the planes we worry about is the actual board itself. But then this would have a, they use a cursive P. How do you make a cursive P? Not like that. I don't know how you make a cursive P. Fun, fancy, I don't know, P for plane on there. Okay? Whatever, it worked out. That's why I teach math, okay? And so for this one, you would just call this, the name of that would be plane P. Okay? So those are objects that we are going to mess around with a little bit. All right, so now that we have these building blocks, we can use them to define some other things. And so I don't know if you would like to put these things on the original list that we made on Friday and keep all your geometry vocabulary words in one place, or if you want to sprinkle them throughout your notes, that's up to you. I'm going to throw some things at you here. And now that we have defined the words points, line, and plane, we can use those words in the definitions that we're going to come up with today and for the rest of the year. It'll be fun, Oscar. Already is. Collinear, what do you think that means? You forget, and we're going to remind you here in just a second. Yes?
Same line.
Okay, good. Same line, and what kinds of things can be on the same line? Could you have a plane that's on the same line? No, because planes are like bigger than lines. So what things are collinear? What types of animals, creatures? Points, okay? So collinear is points that are on the same line. Okay? So if I go back to this thing here, can you name a couple of collinear points? A and C, all right? Is it possible to have 2 points that are not collinear? Can you find a way that I could put 2 points on the board somewhere and they do not lie on the same line? Do these 2 points lie on the same line? Yes, I can draw a line through there, right? If I move this point over here, do those 2 points lie on the same line now? Yes, it'd be a different line, but they're still on the same line. If I put these, whoops, Reed wanted to go, were you going straight up and down or something? Are they still on the same line now? Yeah. You'd have to have more than 2 points for them to be non-collinear. Good, so it's not very exciting to talk about 2 points being collinear because that happens all the time. What's exciting is when miraculously you get 3 points that are collinear, or maybe even more than that, because you can see those lie exactly on the same line, right? So these points right here, A, B, and C, are collinear because they are on the same line. And then if I threw another one over here, then those are not. So A, B, and D are not collinear. Does that make sense? Pretty easy concept. Okay, so if we can go collinear, what else can we do? We can go coplanar too. Yeah, good. So 2 points on the same, or points on the same line are collinear. Things that are on the same plane are coplanar. Okay. And we talked about points are the things that are on lines. So we talked about points being collinear. What kinds of things can be on planes? Can you have a point on a plane? Yes. Can you have a line on a plane? Yes. If I draw a line on this board right here, then that is on a plane. Okay. So not only can points be coplanar, but lines can be coplanar as well. So since we've added another dimension, there's more stuff that you can do with that. And so coplanar, we're just going to say means on the same plane. Okay? So really anything that I draw on that board, all of those things are coplanar. As soon as Mr. Stearns gets really mad at one of his classes and puts his fist through the wall and it comes through the board, then that would not be coplanar because it would be sticking out at you. Does that make sense? And you're laughing, but it has happened before. That's why there's a bulletin board back there that hasn't happened. All right, we doing okay so far? Okay, so here are some more things that you came up with from your discussion on Friday. I think, I can't really remember what class had what. And this came up in our discussion today. What's a line segment? Okay, a line that ends. Yeah. How does the book? Yeah, kind of a part of the line. All the points between two endpoints they go with. Okay. So if you pick 2 points and you just want the points in between those two, then you have a segment. If you want all the points that would go extending for every direction, then that is a line. Got it? Okay, so let's go back to this drawing right here. Can somebody raise their hand and name a line segment? Read. Okay, and so what we would say is we would call this piece of the line right there line segment BC. And we'll put a little line segment over the top to show that we're just talking about the points in between B and C and not the whole thing. Okay, somebody else raise their hand and name another line segment. Hold on, is it Trevor?
Yeah.
Nice, okay, give me another one.
Line segment AC.
AC, okay, good. So we could also go line segment AC, which would extend a little bit farther than BC. Colton?
Line segment BA.
Okay, so we could also go BA, and we could laugh a little bit because he said BA. All right, what another one? Yeah. AC, okay. Is that any different than CA? AC, is that what you meant, flip it around? Okay, so AC and CA are going to be the same. Is there another one that you could do? Yeah, right. Just because D is on that line doesn't mean we couldn't talk about this segment right here, because you could draw those points in there, right? So you can do all kinds of different things with that. Okay, so we got lines, we got line segments. What else do we need? We have endpoints. Okay, so Oscar said, what about CA? What's true about those two line segments? They're congruent, right? They're exactly the same thing. And so what we say is that they are congruent to each other, and we use a little equal sign with the squiggly on top. Okay? So congruent means two things that are exactly the same. And like I said, I think a lot of these came up on Friday, so hopefully this is not anything super new. And this is a little bit technical, but there is a difference between congruent and equal. So if I told you that the distance between B and C was 4, and the distance between A and D is also 4, then I can write that in two different ways. I can say that AD equals BC, and since I have no little thing on top, what I'm saying is the distance from A to D is the same as the distance from B to C. So I'm talking about numbers, so I use the plain old equal sign. If I'm talking about the segments, then I have to use the congruent symbol. See the difference there? So the equal sign is used to compare two numbers. The congruent sign is used to compare two objects. And that's kind of a minor detail, but you know, it could be important. Okay, we're almost done. One way that you show that two things are congruent, I don't know if you've seen this before in your other classes, but if these two have the same length, then I can put a little couple marks on there. And since this has 2 marks and this has 2 marks, that means that they are congruent. Even though it doesn't look like it, since I said so, since I put those little marks on there, then you have to believe that they are. Okay? And I could use 3 marks or 4 marks or whatever, just as many as I need so that I can compare the two. All right, a couple more. I know this is more fun than you're probably ready for today. How about midpoint? What's a midpoint? What's true about the midpoint and the endpoints? You're getting the ideas out there, but what is it? What's true about the midpoint and the 2 endpoints of a segment? Good, excellent. The midpoint is same distance from both endpoints. Okay, so can a line have a midpoint? Why not? Because there's no endpoints on a line. Good. Line extends forever in both directions. So a line can't have a midpoint. Segments have midpoints. Okay. Okay, and then I think you also. Oh, and then the midpoint. Stack this on the end. Midpoint. Bisects or cuts it in half. Okay, so since it's the same distance from both endpoints, it cuts the thing in half or bisects the segment. And then the last vocabulary word, and I'm going to do just one example and give you some time to work on some problems. And this also came up, I believe, last Friday. I think Colton gave us this one. What is array? Sure. Was that you on Friday that came up with this one?
Yeah.
Okay.
A line that has a point on one end that extends forever in the other direction.
Good. So array starts at one point and goes forever in one direction. Okay? So we start with points, and then the points we stretched out to make a line. The lines we stretched out to make a plane. Took a piece of a line called a line segment, cut it in half as its midpoint, made a ray extending from one direction. Well, all these things are very closely related to each other. So let's make sure you understand what the heck's going on here, and then you can try some on your own. So if I give you this diagram here, triangle, hopefully. Just get online and the book is online, right? All right, so if you have that diagram right there, somebody raise your hand, name a midpoint and the segment that the midpoint bisects. Cool.
Point F, bisects line CV.
Line segment CV, yeah. F bisects segment CD. And how do you know that is true?
Because it shows that there's two.
Right, so it's 2 centimeters from point C, it's 2 centimeters from point D, so obviously in the middle, so it's the midpoint that bisects the segment. Good, very good. Somebody else, another one. Yes, Lauren.
Point K
Okay, we can also say that K bisects segment JL, and this time we didn't have numbers on the diagram. How did she know that? Right, because this has two little slashes on it and this has two little slashes on it, so these pieces are the same, so K is right in the middle. Okay, good. Any others? Dylan?
F bisects
F bisects EG. So this guy right here is in the middle of these two. How do you know? Looks like it, but do we know? No. So, trick question. There aren't any other ones up there, so that was mean of me. I tricked you. There are some that look like they might. F looks like it's right in the middle of E and G, and N looks like it's right in the middle of M and P. But unless you're told specifically, either with these marks here or by the distances, then you can't say for sure. All right? Yeah. Great question. Does H bisect JL? It's the same distance from each one of them, right? So does H bisect JL? Why not, Reed?
Because it's not on the same line.
Because it's not on the same segment, right? So it needs to not only be the same distance, but it also needs to be on the segment, okay? So, good. All right, everybody all right with that? All right, I think that we are good to go. All right. So we were gonna do this all in one day, right?
Yeah.
Okay, so that works. Anybody else a little warm? A little bit?
Yeah.
Kind of chilly.
Kind of chilly? As you guys do your homework, will you make sure that you put the period that you're in on here? Because I'm just still learning names a little bit, not sure who's in what class. That would help me out quite a bit. All right, because then we're going to do midpoint.